Earth Systems 3209, Unit 5, Earth's Resources. Reference for this unit can be found in Chapter 21 and Appendix A and B within the curriculum guide. Unit 5, Topic 3.5. This topic will look at extracting and refining of petroleum. We will focus on identifying and describing the two main means of extracting petroleum from Earth. We will also focus on identifying and describing the methods of refining petroleum, and focus on the distillation column to help explain this process. When looking at extracting petroleum from the Earth, two main means of extracting petroleum from Earth can include drilling and surface extraction, which is more commonly called open pit mining. Diagrams below demonstrate what will occur during drilling within water and open pit mining on the Earth's surface. Let's look at drilling as one of the extraction processes used to extract petroleum from the Earth. Drilling can take place on land, ice, or water. A proportion of the petroleum in a trap is under natural pressure, and therefore will be released naturally when tapped by the drill. Another proportion of the petroleum will remain in the trap due to loss of pressure. Thus, other techniques will be required to get the remaining oil from the trap. For example, we can pump in water, gas in the form of steam, and also fill the reservoir with other liquids. If we look to the right, we notice that steam injection is used to inject steam within the reservoir, which helps the oil become mobile and can later be pumped out. The second method of extracting petroleum from the Earth is called surface extraction. Surface extraction is more commonly called open pit mining, and this is the case in Alberta, where the Alberta oil sands is an example, where petroleum is extracted directly from the surface by open pit mining. The petroleum migrated toward the surface, and volatiles such as water and gases were lost to the atmosphere. As a result, this increased viscosity or thickness and prevented the oil from spreading out and dissipating. As a result, the oil accumulated within the sediment. The reservoir consisted of loose, unconsolidated sediment that exhibited high porosity and permeability, but it never had a caprock. Therefore, the oil could migrate through and accumulate within the sediment. In some cases, steam is injected directly into the tar sands to mobilize the hydrocarbons, which are then recovered from pumps, much like the conventional crude oil method. Example of this can be seen in Fort McMurray's Athabasca oil sands. When we look at refining petroleum, there are different methods used to refine petroleum, and these can include distillation. During distillation, crude oil contains hundreds of different types of hydrocarbons, and they're all mixed together. Different hydrocarbon chain lengths all have progressively higher boiling points, so they can all be separated by the process of distillation, where you heat the hydrocarbons up and let them cool slowly. And at different temperatures, different hydrocarbons will condense from the distillation chamber. Once petroleum is extracted from the subsurface and is desalted and dewatered, it enters a distillation column. Here, heat is added to the column to separate the petroleum into fractions based on boiling points. This process of separating due to temperature and heating is called cracking. The bottom fraction is removed to another column for further separation. So if we refer to the diagram to the right, crude oil is entered into a blast furnace. In the furnace, the crude oil is heated up to temperatures that exceed 400 degrees Celsius. At 400 degrees Celsius, certain hydrocarbons would come out of the gas component, these including lubricating oils, paraffin wax, and asphalt. Once they condense out of the gas component, they will settle in the bottom of the distillation tank and are extracted for further processing. The remaining gases will pass up through valves, and these valves will then enter another chamber which is at a lower temperature. For example, the chamber above the bottom, the second chamber from the bottom, would be approximately 370 degrees Celsius. In this chamber, fuel oil will no longer stay in a gas state and will condense to liquid form. This fuel oil then will be extracted for further processing. The gas then that remains will move up to a third chamber, higher in the distillation column, where the temperature is approximately 300 degrees Celsius. At 300 degrees Celsius, diesel oil can be extracted from the distillation column. The remaining gases then move up into another chamber where kerosene will condense and be extracted from distillation column. And then finally, at the top of the distillation column at approximately 150 degrees Celsius, this is where we see gasoline or petrol condensing, where it is extracted from the distillation column. All the remaining gases, which then are roughly below 150, are then extracted through the top of distillation at approximately 20 degrees Celsius. So this process, which uses a distillation column, will show how different hydrocarbons are extracted from the crude oil at different temperatures. And this process is called cracking. The second method, which further refines petroleum when separation occurs, is the process of cracking. Cracking processes breaks down heavier hydrocarbon molecules, which have high boiling points, into lighter products such as petrol and diesel. This is done by catalytic cracking and also can be done by thermal cracking. Catalytic cracking is a process used to break crude oil down into gasoline, kerosene, and fuel oils. And thermal cracking is a process in which hydrocarbons such as crude oil are subjected to high heat in order to extract usable components during the cracking process. A third method used to help refine petroleum is called reforming. During the reforming stage, reforming involves the conversion of straight-chain hydrocarbons into branched-chain hydrocarbons, such as gasoline. This type of refining of petroleum involves heat, pressure, and the use of catalysts. These catalysts can speed up the reaction rates and help reform different hydrocarbon compounds at a much faster rate. So reforming involves heat, pressure, and the use of catalysts to speed up the reforming of different hydrocarbon compounds. Let's look at some examples from past publics. First question reads, which applies to the vapors at the top of the distillation column? The vapors in the distillation column that's located towards the top part of the distillation column will be at lower temperatures. So we see that these hydrocarbons would have short chain molecules with low boiling points. So our answer to example number 1 would be C. Question 2 reads, which is the refining method and involves the use of heat, pressure, and catalyst? So heat, pressure, and catalyst is used in the refining method, which we know as reforming. When we reform different petroleum products, heat, pressure, and catalysts are used to speed up the reactions. So the answer to example number 2 will be C, reforming. Your turn. Take the time and complete the following question. You can pause your recording now to prepare your answer, and the answer will be on the following slide. The question reads, at which location in the distillation column would you collect the lowest boiling point hydrocarbons? If you notice, in the distillation column, the highest temperature will be at the bottom and the lowest temperature will be at the top. That is the premise by which the distillation column operates. As we move up the different layers or the different areas within the distillation column, the temperature lowers. And at lowering temperatures, different hydrocarbons will condense from the gases components. Therefore, if we were looking for the lowest boiling point hydrocarbons, we would find them in the highest chambers. And according to this distillation column, the lowest boiling point hydrocarbons will be found at location A. So the answer to this question would be A. Let's look at an overview of the points covered in this presentation. We see that petroleum can be extracted from the surface by two methods. We can use drilling, which takes the petroleum products from deep beneath the surface, or we can use open pit mining, which is surface extraction, which refines and retrieves hydrocarbons that are near the surface. Once hydrocarbons are refined and collected, petroleum can be refined using the following methods. Distillation, by using a distillation column in which the different hydrocarbons are collected at different temperatures, and refining hydrocarbons by use of heat at different temperatures is a process called cracking. And thirdly, we refine petroleum products, namely hydrocarbons, by a process called reforming, where we use heat, pressure, and the addition of catalysts to speed up the reaction rates to refine the different hydrocarbons. So these are the main points that are involved in this presentation.